Hello everybody, Miss Germany here again with yet another multi-step equation. So this one is another one with fraction, and what we have is the quantity of 4 minus x divided by 5 equals negative 5. All right, so once again we're going to use our solving equations decision chart. Are there fractions or decimals to be removed? Yes, definitely have fraction. So once again, I want to find the LCM. Now the good news is when you only have one denominator, as we do in this case, the LCM is that denominator. All right, so it's really nice when you've only got one or they're all the same, because then your LCM is just what you have there. So we're going to multiply both sides of the equal sign by the LCM of 5. And again, I'm going to put 5 over 1 on the side where there is a fraction. But over here on the right, it's probably easier just to show the 5. Now, the reason we use the LCM has to do with the fact that these 5's on the left will now cancel. 5 in the denominator, 5 in the numerator cancel each other out. And so all I have to bring down then on this left-hand side is 4 minus x equals, on the right-hand side, I have negative 5 times 5. Well, again, multiplying different signs, your answer is a negative, and so 5 times 5 is 25. So I have 4 minus x equals negative 25. All right, so I got rid of my fractions. Okay, so what do I need to do? Does distributive property need to be used? Nope, no distributive property that I need to worry about there, so I can say no. Are there like terms on the same side of the equal sign? All right, so let's draw that line so that we can see our two sides of the equal sign. All right, and do I have like terms? Well, 4 is a constant, x is a variable, not like terms. Then on the other side, I just have a constant. So the answer is no, no like terms. Are there variables on both sides of the equal sign? Well, the only variable I have is here on the left, so that's a no again. So this means I'm in a two-step equation. Are there constants on both sides of the equal sign? Well, on the left I have 4, on the right I have a negative 25, so yes, I do. So I want to add or subtract to move the constant away from the variable, okay? So my variable's on the left, which means I'm going to move the 4. Now remember, it's what's in front of the 4 that determines the inverse operation. So the 4 is a positive. So the inverse would be to subtract or use the negative. So I'm going to subtract 4 on both sides of the equal sign. That is going to enable my 4's to cancel here on the left. Now be careful, do you see what we need to really watch for right there? Watch for the fact that that x has subtraction or a negative in front of it. So that's got to make sure we stay. So we have negative x equals, now negative 25 minus 4. This is where my signs are the same, so I'm really going to add them and keep the sign. So both are negative, so I'm going to keep the negative. 25 plus 4 is going to give me 29. All right, so then, is there a coefficient with the variable? Now, this is a little bit of a trick question because yes, there is. And the way I really know it, there's always a coefficient of 1, but the important thing is that negative, and this is why we need to understand that. So note, there's not just 1, there's actually negative 1. So I do have to use my division because I need to get rid of that negative, so I'm going to divide by negative 1, because when I divide and my signs are the same, it becomes a positive. So I'm going to divide both sides by negative 1, which will then enable my negative 1's to cancel, all right, leaving me with just x. Now my variable does not have a coefficient other than 1. And again, negative and a negative gives me a positive. 29 just divided by 1 is 29. So x equals 29.